Artemis II project explained. The Artemis project is a space program created by NASA and supported by other space agencies such as the European Space Agency ESA and the Canadian Space Agency CSA. And its primary mission is to lay the groundwork for bringing the next generation of humans to the Moon and subsequently Mars. The Artemis project consists of 3 stages. In previous videos, we talked about some estimated dates for the launch of the Artemis project, as well as the inconveniences that have delayed its start and the details of Stage 1 called Artemis 1, which will be responsible for testing the Provisional Cryogenic Propulsion Stage (ICPS) and the Orion module around the Moon. If you want to know what that first stage consists of, you can check the video out here. Artemis II. Artemis II is the second stage of the Artemis project and will consist of a series of human crewed missions aboard the Orion spacecraft. In this mission, the astronauts will prepare for the next ones to establish a base on the Moon. Mission: Artemis II will be the second stage of the Artemis project. Its launch date will be subject to Artemis 1, and its main objective will be to bring to the Moon instruments and astronauts who will make preparations for the safe arrival of humans. The liftoff of the mission will be the same as with Artemis 1, a Space Launch System (SLS) that will carry the Provisional Cryogenic Propulsion Stage (ICPS) and the Orion spacecraft with a crew of 4 astronauts. Once the SLS reaches the Earth's orbit, it will decouple and return to Earth. On its own, the ICPS will be in charge of taking the Orion spacecraft to the Moon with fuel based on hydrogen and oxygen. Unlike Artemis 1, where ICPS primarily used the Earth's gravitational assistance to propel itself to the Moon, Artemis 2 will use only ICPS fuel to leave Earth as soon as possible to prevent the crew from lying too much time inside the Van Allen belts. Van Allen belts. The Van Allen belts are 2 ring-shaped areas around the Earth where high concentrations of radiation can be dangerous for living beings. To prevent astronauts from suffering damage from this radiation, the Orion spacecraft will be equipped with a coating consisting of a double layer of aluminum filled with Kevlar, the material used in the anti-water brake Echo shawls. This is because NASA engineers found that 2 thin layers of protection offer better protection than a thick layer. This ensures their protection from radiation and impacts from small space bodies such as meteors or space debris. Despite this protection, a small percentage of radioactive particles manage to cross the ship's defenses and reach the astronauts' bodies. However, they are very mild doses of radiation. If a human receives it for a very long period, more than 10 hours, it will cause irreversible damage to the body, causing cancer or aplastic anemia over years. To avoid this, all astronauts have to spend as little time as possible inside the Van Allen belts. This way, the Orion spacecraft will traverse the Van Allen belts in no more than 2 hours, a perfectly reasonable time. Once the spacecraft has passed through the danger zone, the engines can be turned off and the craft will be driven only by the inter-island gravitational pull force of the Moon, having to turn on the machines only to make minimal direction adjustments. On the Moon. Once the crew reaches the Moon, they will begin with studying the lunar surface, making a bunch of orbits, getting to the very remote regions, including the dark side of the Moon. As you know, the Moon has a face always facing the Earth. This phenomenon is known as tidal coupling and has been observed in other solar system bodies and extrasolar planets. Because of this, astronauts will be able to see from the windows of the Orion spacecraft the far side of the Moon and the Earth in the background as the vast and bright blue sphere that gave life to the human race. During their stay in lunar orbit, astronauts will study the terrain, specifically south of the Moon, and determine the best region for their companions on upcoming missions to land. Why is the south of the Moon so important? Unlike the Apollo missions that landed near the equator of the Moon to have regular communication with the Earth, the tasks of the Artemis program have established landing at the South Pole. NASA has the Stratospheric Observatory for Infrared Astronomy, SOFIA, a 2.5-meter diameter reflecting telescope installed on a Boeing 747 SP aircraft modified to scrutinize space from Earth's atmosphere, allowing it to exceed 99% of Earth's atmospheric layer, a position from which it can obtain data about the solar system that are not possible with the terrestrial telescopes. After NASA scientists thoroughly analyzed the data and observations made by SOFIA, they discovered that large reserves of frozen water exist in the large, cold, and deep craters of the polar regions of the Moon. In addition, they revealed that in the South Polar region, where the Lunar Prospect mission found water in the late 1990s, there are similar, shallower depressions that could be cold enough to retain moisture for thousands or millions of years. If proposed is to establish the first lunar base, water will be fundamental to achieve this. If future missions somehow manage to extract these reserves of frozen water at the poles and take advantage of them to meet human needs, it means a massive leap in the use of resources of our solar system to expand the human race. Artemis II astronauts will study the terrain in conjunction with the artificial satellite Moon Reconnaissance Orbiter, which has already provided geographic data of the lunar landscape and craters. This will help them determine which is the safest and most stable region for the moon landing and those craters that could contain the most significant water reserves. After spending 4 days orbiting the moon, and once they have conducted the relevant studies to determine the moon landing zone, the astronauts' mission will be over, and they will embark on a journey back to Earth. Return trip. During the one-way trip to the moon, the ICPS would have spent a lot of fuel to leave the Van Allen belts as quickly as possible. Because of this, it is likely that the astronauts do not have enough energy to propel the spacecraft to high speeds and decrease their stay in space. Fortunately, that won't be a problem for 2 reasons. The first is that the ICPS has sufficient supplies and reserves of water, food, and oxygen for astronauts to stay in space for up to 3 weeks. And second, because that will not be necessary, since for the return trip, the ICPS will use the gravitational assistance of the moon to propel itself towards the Earth, and once it leaves the influence of the moon, it will be attracted by the gravitational influence of the Earth. In this way, only using the gravitational attraction force, the astronauts will be able to return home. Once they reach Earth's orbit, the ICPS will decouple, and the Orion spacecraft will enter Earth to make a safe return, just like Artemis 1. Next missions. So far, the human crewed mission will officially end. However, Artemis 2 also contemplates sending tools and equipment that will be fundamental for astronauts landing on the moon. The following missions will carry more than 100 kilograms of equipment that will serve future astronauts to collect lunar samples, perform measurements and monitoring of the soil, and repair anything that will spoil. Another critical piece of equipment for astronauts will be a pressurized rover like the one used by the Apollo 17 astronauts to move around the lunar surface more quickly and explore a larger area in search of water deposits in lunar craters. Artemis 2 will also be responsible for leaving on the moon a series of equipment that will serve astronauts to perform chemical tests and determine which materials are on the surface. And finally, one of the most critical equipment for the Artemis project, the Gateway. Gateway. The Gateway will be an outpost in orbit around the moon that will provide vital support for a long-term human return to the lunar surface, as well as a stopping point for deep space exploration. It is a critical component of NASA's Artemis program. Like the International Space Station, the Gateway will remain orbiting the moon, a mandatory stop for all future astronauts planning to land. Because of this, NASA has focused the development of Gateway on 3 initial critical elements needed to support the moon landing. 1. The aspect of power and propulsion. 2. The housing and logistics outpost, HALO. 3. Logistics capabilities. 1. Power and propulsion element. The power and propulsion element, PPE, is a high-powered 60 kilowatt solar electric spacecraft that will provide power, high-speed communications, attitude control, and orbital transfer capabilities for the Gateway. It will be one of the critical pieces for sending ships to the lunar surface and the safe return of astronauts to Earth. 2. Housing and Logistics Outpost, HALO. The HALO will be the initial crew cabin for astronauts visiting the Gateway. Its primary purpose is to provide basic life support needs for visiting astronauts after arriving from Earth and preparing to descend to the lunar surface. It will provide command, control, data management capabilities, energy storage, power distribution, thermal control, communications, tracking capabilities, environmental control, and life support systems to augment the Orion spacecraft and support crew members. It will also feature several docking ports for visiting vehicles and future modules and space for science and stowage. It will also have an architecture similar to the International Space Station, the ISS, to make it easy for astronauts to adapt to their systems. 3. Deep space logistics. As astronauts prepare for missions to the lunar surface, they will need deliveries of pressurized and insured critical cargo, scientific experiences, and supplies such as sample collection materials and other items. In March 2020, NASA announced SpaceX as the first U.S. commercial supplier under Gateway's logistics services contract to deliver cargo and other supplies to Gateway. A delivery of logistics services is planned for each crewed Artemis mission to the Gateway. This will provide a regular shipment of equipment and materials to ensure an extended stay of humans on the moon. Everything ready for Artemis 3. It's been more than 50 years since humans last went to the moon. The human race has always had a tireless desire to explore the world, an intrinsic need to discover new things and reach the limits of our abilities. The Artemis project isn't just about getting back to the moon. It's not just about establishing a base and harnessing the natural resources of our natural satellite. It's so much more. It is a reason to join forces, a reason to cooperate among nations and achieve a common goal. It is the ultimate representation of the ambition and desire of humans to go further. The Artemis 2 missions will be the ones that prepare everything for the arrival of the next generation of astronauts who will put their feet on the moon. The success of this stage is fundamental not only for the Artemis project, but for the entire human race. This is where the future will be sown, the next rung of history, and we will be the art of it. Do you want to know what the last stage of the Artemis project will consist of? Then we suggest you subscribe to this channel so you don't miss the following video.